quarters all raised to the 3.
Plus 12, all over 4 plus 9 quarters to the 3 halves. But this is nothing more than the square root of, is that 81 over 4 plus 9 quarters cubed? Plus 144 over, is it the same thing?
Calculator time.
Yeah, calculator time.
What if you're on a desert island? How are you going to finish the computation?
You're going to get up and go look for coconuts. You're going to make a coconut-based, gravity-driven calculator.
Just
I like that.
simplify it.
Or you're going to yell and scream for help.
See what you get. You might get something pretty.
I doubt it. How on earth?
That's not bad, is it, you guys? Yeah, I'll wait. Okay.
Once
You factor out a 64, that's a square.
cube is 244, and then 1 over that times 81 is 0.33. What the heck?
Yes.
I think you combine the 9 and 9 fourths
The 9 and 9 fourths?
on the bottom before you pull out the 64.
I did, and I did it incorrectly.
6.
I'm so sorry, Alex. It should be a 25, isn't it?
Yep.
My apologies. It's just arithmetic, you guys. You know what my arithmetic?
Then you can just take the root
No.
of 25,
Yeah.
right?
4
You
plus
just got
9 over
5, so it's
4
125.
cubed is 4 plus 9 over 4 cubed.
Okay,
9
do
divided by 4
this. Watch. I'm being lazy.
cubed is 244.
But watch. If I pull out a factor of 1/4 from these two terms, that becomes a 16. But now when I pull the 1/4 out of the cubing, I got a 1 over 4 cubed, which is 1 over 64. I just inverted and multiplied.
18. Oh, that's not 18.64. That's 18.
No, 18 times 64.
Okay.
I can't write my points any neater than this. I
Why
can't.
is it 18? Isn't it supposed to be 81?
No, on Fridays, 18 and 81. Thank you. See, I wrote it over here, but when I moved over here, I just changed it. That changes things. Ay. Okay, that was embarrassing. I guess I gotta finish up. Is that gonna be I can pull out a 9? You guys make me do all the work.
That should.
Why'd you put it over 1?
Wait, what?
45 is. Oh, well, okay, so about 6.7.
You're yawning, I'm sorry. I'm done.
Okay.
No calculator. So I think that's the curvature. Well, at that particular value of p. Oh no. After all that work, shoot, we never answered the other question.
It's just enough.
It's just 1 over that. So it's 125 over 7.
That is the k value.
That is my k value. Do you see why earlier Linda said, well, I'm not going to concern you with formulas exactly, just because my numbers aren't going to turn out to be as nice as yours.
Would you divide that by sat?
No, I'm not saying that answers the question. I think I came up with value. Curvature is not finished yet.
So curvature at time equals 1/2. Or t equals 1/2.
Yeah, I'm just saying, pick that number up, we're gonna plug it in to come up with the actual curvature value, and I get the number I just came up with, which is 72 root 5 over 125. All over my r bar prime, which was, I can't read, it's 2t, it's 2t.
R bar prime is t and root 4.
How about none of them? Because we want the magnitude of our prime.
Yes, I know, that's what I'm giving you.
Oh, okay.
It's t root
So 1/2 root.
4 plus 9 over 4.
Are you guys happy?
You're gonna have to.
You have to simplify.
So that isn't our k value yet.
Yeah, this is the actual k value. If I said it, I don't know what I said, Linda, but this is my k value. Once I get what t bar prime's magnitude, now I'm finished. Plug it in, and I have no idea, you guys, what I get. It's like 125 times, whoa, 4 over 5?
Okay, 9 divided by 4 plus 4 is 6 1/4.
The 1/2 went upstairs. I did this.
That's 25 over 4.
2 times 2 is 4.
Square root 25. Oh, so it's just 5 over 2? 5 over 2 times 1/2. So it's 5 over 4 times whatever that stuff is on the other side.
Yeah, you guys double check my arithmetic.
So
I'm
it's
hoping.
So it's 4 times
288 root 5 over 625?
Yes, that's a nice number.
You know, the other Math 32 class is well into chapter 12 right now.
Yeah, I know, I'm behind. But I've been sick. We
Okay.
had some holidays, so we've been really shafted with that. That's why a lot of faculty do not like to teach any Monday, Wednesday, Friday classes, because we lose so many hours.
Yeah.
Yeah. Because all holidays fall on Mondays and Fridays. So, you guys, can we just finish? The circle is just as reciprocal.
Yeah.
Good, we can't stop, we're not finished. I hope I asked for the equation of the oscillating circle. I didn't, that's what I meant. Let's get the equation of the oscillating circle.
We know the radius though.
Yeah, we do know the radius.
Yeah. Everything we have
So now-
the point.
We have a t value.
Oh, no.
What would the equation of the oscillating circle look like, you math D experts?
You just plug that into the equation of the circle with, that equals the radius that we got when we're done.
So x minus h squared plus y minus k squared
Yeah.
is equal to my r squared. Well, actually, I'm not going to write the r squared, because I think my r squared is going to be nothing more than 625. Actually, wouldn't it be a 625 squared?
Oh.
Can you guys give me the rest? Can I erase?
Yeah.
Shoot, doesn't work. We don't have the h and k.
Why did you invert the your k value?
Because
I'm sorry.
it's a circle.
Yeah, yeah.
It's a circle.
Okay, so what, to get h and k, if we have a point at t on our curve, why couldn't we just go, find the normal vector to our curve at that point and go r?
Very nice. And so let's you and I talk about this green vector. I said, let's talk about this green vector.
Well, that's our unit tangent, that's our unit tangent vector.
It's green, yeah.
It's our unit.
You're not going to write that on the next exam.
Yeah, that's.
It's our unit tangent vector, right? Isn't it? Or it's our tangent vector.
That's our, what are you normal?
What? No one's going to help me? 3/4?
Okay, why, where are you getting those values from?
Isn't that r bar prime?
Okay.
Yeah.
Oh, this is our direction vector
Yeah,
at.
you're the one who told me.
At 1/2.
Correct. I'm sorry, I thought you had
One
it.
out there.
That's our position vector, that's not our direction vector, that's our position vector.
The position vector is one I just erased. The position vector is r bar. Right? And I'm using r bar prime.
Which is our
Isn't it right there?
No, I said I just erased the r bar. He asked about the position vector. I said I erased the position vector.
Isn't R bar the position vector?
Yes, but
that's
that's
r
r bar prime.
Oh.
It is a Friday. So you guys, who cares?
Well, we need to find a vector that's directly 90 degrees to that, so we can go r.
Oh, so you
distance
mean pull out
along.
a different color pen?
Tangential vector to the circle.
That is tangential, what do you mean?
Find a line perpendicular to that green vector.
Very nice.
And then
So I think to connect from here to the center, I can draw myself a nice little triangle. Now think about it. With this green vector, I'm running horizontally 1 up 3/4. Or I would say, I'm running 4 up 3. So shouldn't I back up by 3 times something? I'll call it C. And up 4 by times the same darn thing. Whatever that thing is.
Why are we doing that if we now have a point in the circle?
Why doesn't it need the center? We have the radius.
I mean, I suppose you're right. I could have gone in that direction. Can I put it back on the board by a raise? You're saying use R bar and T, which was, I don't know, was it T squared and T cubed, I think?
Yeah.
I mean, correspondingly, I guess I could have put in, let's see, what did I put in for X?
1/2.
Good. In other words, not this. We're going up to our T value 1/2, putting into the position function, and that would give us a point right here, which is
1/4.
1/4 comma
1/8.
1/8. I'll do that for you.
And that's the same thing as the 4C, 3C thing that you're doing.
Well, if I plug that into the equation of the circle, I mean, would that allow me to find H and K?
Let me think here.
Yes, I will. I'll let you.
Much as easier.
What about finding a vector that's normal to like our velocity vector there? And
That's
then
what I just did.
okay,
With
I'm
the
not
hypotenuse of the triangle.
Do you think the hypotenuse is?
Because you guys were going too many questions. Let's go back. I don't have no problem plugging this point in. We can use this point. It's just when I plug it back in the original equation I have in the very top left board, I still have an equation 2 unknowns. It doesn't help me solve for H and K, does it? Now do you like my triangle?
now where did that triangle come from again? How exactly?
I'm sorry, Catherine.
You reset that to 3 before, and then.
Yeah, can you do this, Catherine? I was being lazy. I thought the fractions were too confusing. It really is a Friday. So in my head, I multiplied this vector by 4. It was just easier for me to deal with. And since this says, for the tangential vector, I'm not the unit one, just a tangential vector, that I'm moving 4 horizontally and 3 up, I think if I'm going to meet it at a right angle, I'm going to go in the other direction, 3 horizontally, but to the left, not to the right, and 4 up. Because back at Math D, you recognize that slopes of perpendicular lines are negative reciprocals. This is just Math D extended.
It seems to
Math
me
D,
like
3D.
all we have to do is do, a squared plus b squared, in which 4c
Done.
plus
And now I think if you solve for C by using Pythagorean theorem, we're finished. Do you guys mind if I don't?
no, yeah.
Yeah, well, all right, I'll start it, but do you mind if I not finish the arithmetic? I'll come to the middle board, we've already used this, haven't we? So I just think I need to find C. But finding C is as easy as using the Pythagorean theorem. So by the Pythagorean theorem, do I not have that 3c squared plus 4c squared is equal to the square of, gosh, I'm getting lost. Is that curvature? Is that curvature? Is that curvature? No, it's radius. And I think the radius is over there at 625. Over something?
288.
Do you guys mind if I do this? Would I know you? Now that I found pound symbol. What do? What do I do?
So that's our,
So this 3c is equal to
3 times pound symbol.
3 pound symbol. This 4c is equal to
4 pounds?
4 pounds.
4 pound symbol.
And that's our H and K, huh?
Is it really?
Sort of, no.
Sort of, not really.
Well, that's the radius vector. Wouldn't that represent, well, the distance from that point to the center? If you were to think of it as like a distance vector?
Yes. So how am I?
You know,
Thank you. I agree with that. I think to come up with H, is H merely going to be, look at my picture. The x quarter of the center, that's what H is, of the circle, is going to be this x quarter 1/4. Minus, I don't know, is it 3c? But according to my picture, I think K, that's not curvature by the way, that's K up there in the equation of the circle. I think that K is going to be nothing more than, well, this y coordinate 1/8, increased by, well, this vertical deviation to the center, which is going to be 4 times c, or 4 times pound symbol. If you guys aren't annoyed with me by not finishing what pound symbol is. I'm just trying to beat the clock, you guys.
Isn't there like a easier way?
I don't know, is there? I can't think of one. Why would you want something easier than that? That's so pretty in the picture.
Would this be a problem to have on an exam?
Probably.
Probably.
You'll be so proficient by then, don't worry about it.
Do we
That's
have
a
these
definite
problems
yes.
in the book?
They better. You guys, do you think I can start flying?
Do you wanna keep talking and then we just take on things?
What do you want?
To take over.
No, no, no.
No.
I've got a very easy in-class quiz, or we can just,
Let's do an easy in class quiz. Because easy points are always good, right? Easy,
Define easy.
if it's arc length, I mean, come on, how hard is that? Seriously.
Hard enough.
I mean, were any of those problems like challenging in the book? I mean, I know he
No,
can
I
write
didn't have a chance
challenging
to start on
problems,
some
but
basic
Yeah,
physics
yeah,
and
all the ones
statics.
before were too easy.
yeah, I know, seriously, right?
We only have like 9 minutes left of class, we wouldn't have time to finish it anyway, so let's just listen to the
Yeah,
lecture.
I don't think there's lecture.
Yeah, let's finish the lecture. Then we get a take home quiz. And there goes my
hi, racist.
there goes my wisdom.
Oh, just as many quizzes as I can get. My chances of a better grade are higher.
That's
Yeah.
fine.
Yeah.
I got.
Well, the quizzes are optional.
No, they're not.
Yeah, they are.
No, they're not.
Professor Balaguy, are the quizzes optional?
All quizzes are optional.
There we go.
All the tests are optional. You don't take any of them.
Optional like class attendance is optional. See?
Yeah.
You guys check this out. I think, when it comes to acceleration vector for a curve in free space, or a curve in any place, excuse me, I shouldn't have said that. I think I can break it up to a tangential and normal component. In other words, I'm forming a rectangle here.
Okay, my question is, what should we be titling this? You haven't even given me something right yet.
Yeah, I never do, but if you just bug me.
Okay, then I'll
Oh,
bug you.
this is a quiz?
No, this is not.
It will be a quiz in a day or two.
So I'm just taking acceleration, sort of like what Matthew was bringing up at the beginning of class, and breaking up two components, namely horizontal and tangent. This is horizontal. Namely tangential and normal.
So could this be used for something like a particle moving through space on a non-constant
Yes,
field?
absolutely.
Okay.
Yeah, and so basically, I'm going to have
The sum of the
a tangential vector and a normal one, which are the components tangentially and normally for the vector A, meaning I can form myself a nifty little rectangle here, is what I'm really suggesting.
So they're like vectors inside vectors, so you can have like 4, 5, 3-dimensional space, and that like in your like vectors describing the acceleration and or the tangential and normal acceleration.
Yeah, and I don't know if I really care what dimensional space you're in. All I care about is that you can break this acceleration up to normal and tangential components.
Okay.
Let's do it.
But I'm not like thinking instead like going because like in physics all we have is just things going around in circles. Like you have like a ball on the string. And
That's
just
all you have?
yeah, that's all we really did.
Oh, you mean so far? I get it.
Yeah, but I'm thinking like in 3D space, like because we were asking her like what happens if you like twirl the ball around like that and have like the ball going around to describe the normal and like to describe the acceleration of that, you would just use, you know, like x, y, and z instead of just x and y for the tangential and normal components. Would you do that?
Yeah, you might break it up to actually different planes instead of just vectors.
Okay. But it all still comes back to like that, the equaling acceleration.
Yes, in the end, you're going to be summing those together to come up with the same darn acceleration vector. I agree.
Are the colors unit vectors?
No, they're not.
Just direction.
They're just a magnitude of my normal and tangential components. And let's see what it turns out to be. Isn't V bar this?
You mean A bar or?
V bar, the velocity is the particle. I got a particle moving on this curve. Is this velocity described as such? Or the V is just a magnitude of V bar?
So magnitude is V bar times t is what again? Sorry.
T is a unit tangential vector, so it's going in the direction of this black one, but it's going to be a unit vector. Its magnitude is just 1.
So we have magnitude of v times.
I mean, isn't that just a basic definition of T bar, you guys? T bar goes in the same direction as R bar. It's just that I'll divide out by R bar's magnitude. It's just that R bar prime's magnitude. It's just that R bar prime is sometimes thought of as a V bar. That's an R, a V, and I can think of this as V. But if you multiply both sides by V, oh, look at that. You get what I just said. Yes?
Okay.
And if I were to differentiate with respect to T, I would simply get this. Oh, the derivative of the first times the second as is, plus the first as is times the derivative of the second. But I think the derivative of V bar is nothing more than acceleration. Hold it, I just made a mistake. And not only did I make a mistake, I don't like my color. Can I change that? Oh, hold it, shoot. Is the magnitude of this vector constant?
As acceleration.
Yes, it's just 1. So what happens when I differentiate? What do we get? I can't hear you. Well, no, T bar is a vector. Differentiate it, what do we get? Its magnitude is constant.
A unit vector?
No, not necessarily.
It's orthogonal.
Thank you. You get something orthogonal to the T bar, which I think will be n bar, a normal vector. I'll call it n bar. It's just that when it comes to the n bar, it's going to be multiplied by well, actually, this one's magnitude. Got another name for the magnitude of T bar prime? I asked, got another name for the magnitude of T bar prime? I can ask it a third time.
And
It is an n bar, a normal vector. The normal vector is this one right here, Glenda. It's normal to the tangential vector. It's orthogonal to the tangential vector. How many times do you want me to ask my question?
You can call it KB.
I can call it K what?
KB.
Oh, so what you're really saying is my acceleration could be interpreted as nothing more than my green V's to V prime. Times T bar increased by, oh, look at this in red, KV squared times n bar. And I have just broken acceleration up into its tangential and normal components. The tangential one is what you see in green. So the magnitude of the tangential vector is just V prime. And the magnitude of n bar is the magnitude of the normal component is just simply KV squared, where V stands for velocity. Can you appreciate this?
Not yet.
I'm going around a corner. But I decided to double my speed. If I turn around a corner and double my speed, the normal component of acceleration quadruples. And you kind of get that feeling in motion, don't you, when you're driving a car? If you increase your speed, it seems like the normal component increases more rapidly, so much more rapidly. And that's exactly why. We can now verify with this breakup into normal tangential components. I think they're difficult to use. So if you guys don't mind, I won't. And if you don't mind, I'm going to describe these two components you see in green and red in terms of something more simplistic. Am I doing okay so far? But this ends up being nothing more than my V bar being nothing more than V times T bar. Times the V prime T bar.
Wait a minute.
Yes, I'll wait.
You multiplied v into this thing in parentheses, right?
Yes, it did.
So wouldn't it be v times v prime times t bar?
Well, what you see above this brace is the same as what you see above this brace.
Oh. So it's the magnitude of the velocity times the tangential vector is equal to, okay, I see it. Alright.
And so you guys can see what I'm actually computing for you I think this is straightforward. Plus my v times t bar. Is that plus, or excuse me, times? V times t bar prime, which is nothing more than the magnitude of t bar prime times the normal vector.
I don't get that.
You don't get this right here, that what's above this green brace is this.
Yeah.
Then check this out. Before you differentiate, you got t bar. Now t bar's magnitude is constant. And I proved to you in class that if I got a vector value function whose magnitude is constant, then it's going to be orthogonal to its derivative function. And if its derivative involves a normal vector, it's got to involve n bar because they have to be orthogonal. That's all I'm suggesting. But these two vectors here and here, are they orthogonal to each other?
Yes.
What can you say about the dot product?
0.
Yeah, I know I got some coefficients in the way, but the dot product's 0. I think this whole term goes to 0. I think I can interpret this as nothing more than, actually, shoot, you guys, look at this. I got a black brace and a red brace. Those are two vectors being dotted, aren't they? But the dot product of two vectors could be interpreted as the product of their magnitudes.
Times the sine of the angle.
Times the cosine of the angle in between, but they're the same vectors. What's the angle in between two vectors that are the same?
0.
0, and what's the cosine of 0 radians?
1.
Oh, isn't that pretty? So I maintain with this equation right here, if I divide both sides by v, I see that v prime is nothing more than the dot product of v bar with a bar all over just simply v. It's a dot product r bar prime with r bar double prime all over r bar primes. Magnitude. That is another way I can compute the tangential component in green of an acceleration.
Is that thumbs in the peanut loop, is that a vector?
Well, these are vectors, that's why I said, oh, thank you. That's the magnitude.
The other thing
In
you
there.
should, yeah.
What about it?
There's a vector?
No, why? Remember I was saying the dot product of these two is the magnitude of this one. Oh, here it is, this magnitude, not a vector.
Okay.
Times the magnitude of this one. Oh, here it is. Scalar value function. Times the cosine of the angle in between. I didn't write it because I'm beating that clock. Guess the only thing I haven't done, I haven't talked about the normal component of acceleration, you see in red. But I'm out of time. It doesn't matter if I'm out of time. It's this easy. When it comes to kv squared, isn't that the same thing as this version of k?
You said kv squared is... So kv squared...
Times my v bar. But that's nothing more than the magnitude of this cross product. Times, oh, look at the v bar. I think, actually, I missed it. It's a v squared, isn't it? My apologies.
Yeah,
Jeepers.
that had me confused for a minute, sorry.
And it's just a scalar. My goodness, I'm just a mess. You guys, look what I'm circling that I messed up on. I was simply trying to rewrite what you see in red.
Oh.
I was just rewriting it. I just couldn't see that one.
Derivative, what is that? Oh, is that a K?
That's my curvature. Like I said, Linda, I'm just grabbing what I circled in red over there.
Okay.
I'm just writing too fast. kv squared, I'm just re-describing it a different way. But you guys, don't you agree that v squared is nothing more than r bar prime's magnitude squared? They cancel. I think I'm merely left with a ratio of the magnitude of the cross product. That would be this thing, crossed with r bar double prime's magnitude. All over r bar prime's magnitude once. If you don't like my notation, this is nothing more than the magnitude of v bar crossed with a bar, all divided by, which is simply the v bar. So you have v bar's magnitude. I only did it this way, you guys, so you see what's inside my circle. It looks a lot like what I have inside this circle right here. Just two different versions.
So are we saying that this is the normal and this is the tangential velocity? Correct?
No, quite the contrary.
Components.
I'm saying this is a tangential and this is the normal components of acceleration, not
Oh,
velocity.
that's right, that's what I meant to say. So that's the normal, that's the tangential, and they're the same?
Quite the contrary. The tangential component involves a dot
Oh,
product.
it's a dot product versus a cross product.
Yes, and I admit they're both scalars, but one's generated from dot product or can be interpreted in terms of dot product, the other in terms of the other, the cross product. Yikes. I'm sorry it took so long. How about diving into section 11.9?
But class was over 5 minutes ago.
And it's gonna start up in another half hour or so for some of us, right?
Yep.
Is that 33?
No, for you.
He's going over hyperbolics in the calculus club, if you're interested.
Oh man, I'm so jealous, but I have work.
Yeah, I don't know. That calculus club sounds like something I need to be doing.
Good idea.
Given that I have almost zero time for homework. So we have a take-home quiz and we have a section out of, oh boy, this is gonna be painful.
Is that an 11?
Yeah.
Okay.
It's okay, this time I actually understood your handwriting, Valley. I don't feel bad.
Oh, you're getting better.
Well, I think it's quite the contrary.
It just looked like you were starting the whole thing off in brackets.
Is that it, or?
11 to 41 odd.